Grace College of Engineering Operating System Laboratory. Lab code is 8461. Fifth exercise. First option is first come first serve scheduling algorithm. Here we will go to learn about the CPU scheduling algorithm, central processing unit scheduling algorithm. See, every process will come to the CPU. So how the CPU is handling and scheduling the particular process. So that particular algorithms we will go to discuss. Many algorithms we are having. First one is first come first serve. So as per the name, it will serve the process. Which one is first come? Okay, first come process will be served as the first. Start the process, number of process in the queue. It will be the number of process will be stored on the queue. So queue you know very well. In the queue, so the first process present in the queue will be served firstly. So some algorithms. This one you have to note it. Calculations. So these calculations only we will go to use in the program. Okay, waiting time, turnaround time, average waiting time, average turnaround time. So the formula here we are using. So you have to study this formula. This formula only will be applied in the program. So waiting time for process. Waiting time for process n minus 1. For the process next waiting time for the process new process is waiting time of process of the old process plus burst time of the process of old process. Turnaround time for process is waiting time of process n plus burst time of process n. So average waiting time formula is equal to total waiting time divided by number of process. Average turnaround time is equal to total turnaround time divided by number of process. So this. So here the above formula here we are writing like this in the programming. Okay, so this is the calculations to calculate the waiting time, finishing time, total turnaround time, and total turnaround time RRR. Has included header file is stdio.h, standard input output.h, main function. Here we are declaring all the variables. This square bracket indicate it is array. 80 square bracket 10. So 80 is the variable, array variable. Array size is 10. From it will assign from the 0 to 9. Okay, 0 to 9. The size 10 means it will assign the array from 0 to 9. So integer data type, variables, two variables. Float data type. Float data types used to accept the decimal point values. See, our result will be in the point value only. Printf is used to print the statement on the output screen. Scanf is used to read the input from the memory. So ampersand n is the variable, contains some value, it is present in the particular address of the memory. So ampersand is indicate the address of the memory of the variable, address of the memory location of the variable n. Okay, percentage d indicates it is the integer variable. Okay, for the float variable we have to use percentage f. So percentage f means it indicates it is a float variable or float value. So here we are using the for loop. For loop syntax is initialization of variable, condition of variable, increment or decrement operator. Printf, scanf, for loop. So here the calculations. Above formulas are here. We are using the calculations. Study that calculations. Then it will print the statements, all the output. So we calculate all the average waiting time, average turnaround time. Every result will be printed at the last. Okay, percent slash t is indicate the tab space, one single tab space between each and every output. So this person, it will print all the first it will print the id of the process, then it will print the arrival time of the process, then it will print the burst time of process, then it will print the shortest time of process, finishing time of process, waiting time of process, total arrival time, total turnaround time. So these are all the, this variable is the integer variable. For that we are declaring it as a percentage t. After printing the process id, it will leave one space. For that here we are using the slash t is used to leave one single tab space between this value and this value. This value is id of process, this percentage d is arrival time of process. Okay, so percentage 5.2 floating. So floating, last one is floating, average turnaround time. This is the variable of floating data type. It will print the value of floating in the decimal point of 5.2. After the point, it will display the digits, 2 digits. Before the point, it will display the 5 digits. It will display the number of 5 digits. Okay, we will run this exercise. Fifth exercise, first option we will run. For that we have to go to the terminal. GCC GNU compiler collection space exercise fifth one dot c space hyphen o output exercise fifth one. To run this program, dot slash here dot slash exercise 5.1. See above on the compilation I mistaken, so again I am compiling GCC exercise fifth one dot c exercise fifth one dot c space hyphen o exercise fifth one dot slash exercise fifth one. Enter the number of process, first come first serve. So I am just giving the 2 process. Enter the arrival time and burst time for the process 1. Arrival time, burst time. Now I will execute. Fifth exercise, second option is shortest job first scheduling algorithm. fifth exercise, second option is shortest job first scheduling algorithm. So here it will schedule the CPU for the shortest time job. Here also we are having some formula. You have to study this formula. So same contents, but the formula only different. Okay, it's like that first come first serve algorithm only, but the formula here, the calculations is different. So you have to study this calculation. It will allocate the CPU for the shortest time job first. Okay, so long time job is allocated the CPU next time. So this formula you have to study. The remaining is same as the first come first serve algorithm. I will run this exercise. For that you have to go to terminal. GCC GNU compiler collection exercise 5th 2.c -o space exercise 5th 2 /exercise 5th 2. GC space ex52.c space -o space ex52 /ex52. Shortest job first. Enter the number of process to be executed. To enter the process arrival time, burst time. So first process for process, next arrival time, next burst time, and the process arrival time, burst time. So this is the output. Okay, next fifth option, third exercise, priority scheduling. Here in third option, priority non-preemptive and priority preemptive two scheduling algorithm we are having. Okay, priority preemptive means priority non-preemptive means not importance for the priority. Okay, so priority preemptive means the scheduling algorithm will allocate the CPU for the highest priority job first. So in the non-preemptive means not importance to the priority job. So the CPU is doing some process at the time, new process is coming with the highest priority means it will not allocate the CPU for the highest priority job. Okay, it will do the same process, it will do the previous job only. But in the priority preemptive scheduling algorithm, when doing one process, at that time new process is coming with the highest priority means the CPU will be allocated to the highest priority job. It will stop the current working process and it will allocate the CPU to the highest priority job in the priority preemptive scheduling algorithm. Okay, so this is the difference between priority non-preemptive and priority preemptive scheduling algorithm. So here also some calculation formulas there, you have to study the formula only. The remaining is the same as the first come first serve algorithms I already explained. So static, here the new thing is static is completed. is completed is the variable, array variable. Okay, array size is 10, and static is the keyword. This is the static is the keyword. So static variable means it have the fixed. Static means fixed, so it have the fixed value. It will not change the new value to the particular variable. Okay, floating point. Okay, this is the formulas for the finishing time, waiting time, turnaround time, total turnaround time. Formula you have to study. Okay, I will run this exercise. Fifth exercise, third option. ECC exercise 5th, third dot C space hyphen O exercise 5th 3. For running, the command is /e exercise 5th 3. Priority not preemptive. So enter the number of process to be executed. I am giving two process and arrival time and burst time and priority. 1, 2, 3, 4 input we have to give. First the process ID, 2 arrival time, burst time, priority. Next one is process ID 3, 4 priority. So this is the output. Next I will run the priority preemptive algorithm. Okay, so that is exercise 5th 3 2. The 5th exercise on that third exercise on that second option. Okay, so GCC space ex532 dot C hyphen O exercise 532 exercise 532. So I'm giving 0 instead of O. O means output. Okay, so again I am compiling GC space exercise 532 dot C hyphen O exercise 532 for running / exercise 532. So priority preemptive. Enter the number of process 2. Enter the process ID, arrival time, burst time and priority. So process ID 2, arrival time, burst time, priority. Our output will be this one. Next one is round robin scheduling algorithm. Round robin. Here we will set the particular time, quantum time. In the round robin, quantum time is there. As per the quantum time, each and every process will be allocated to the CPU. Quantum time slices so it will allocate the time slices 5 minutes or 10 minutes. So after 10 minutes it will jump to the next process, and after 10 minutes it will jump to the another third process. Okay, if whether the previous process is completed or not completed, it will not worry about that completion of the process. It's only focus on the time. If the time of the quantum time is completed, means it will complete the process 1 and it will jump to the process 2, and after completing all the remaining process it will go to the process 1. Okay, it fully based on the quantum time it will be work. round robin CPU scheduling algorithm. Here also some formulas available, you have to study the formulas only. Timer, so in the round robin algorithm you should use the timer variable. You are allocating the quantum time. Okay, this is the new one. I will run this program also.